So number 9 says, the length of a rectangular speaker is 3 times the width. So Nina, if I said the length is 3 times the width, do you understand how that means that if you take the length, it's equal to 3 times the width?
Yeah, I get that.
Can you guys hear me, or is that really loud? Can you hear the motor in the background? Is that really loud or no?
I can hear it a little bit, but not that much.
Okay. All right, so Nina, does that make sense?
Yeah.
All right, the next thing, I'm going to ask you to help me out. So think about this, okay? Always, what I try to do, Nina, with word problems is I try to make them make sense in real life, and then I try to apply that real life to this word problem. So here's what I mean. If I said, and the height is 4 more than the width. What if I said, Nina, I have $4 more than you? What would you do? You have $10. I have $4 more than you. How much money do I have?
14.
How did you do that?
I added 4 to the 10.
Okay, so if I said the height is 4 more than the width, the height is equal to what?
Would it be 4W?
Remember what I just said to you? I have $4 more than you, correct?
Yeah.
Did you times your money times 4?
No.
What did you do?
Added.
So can you please do that same thing here? Does that make sense how I'm trying to relate those two?
Would it be 4 plus W?
Or W plus 4.
Okay.
Same thing. That's just community property. I would rather write the W first. But yes, that's it, right? 4 more than the width. That means you have 4 more than what? The width. So you take the width, add 4 to it, and boom, you've got how much the height is. Now it says, can you find the volume? Well, what's the volume of a rectangular prism? You should know that from geometry. Do you know the formula for it?
I don't remember.
How do you find the area?
Is it something like length times width or something?
Yep. And then for volume, now you add a third dimension. So it's length times width times
height.
There it is. You do know it. Now, they said they want this formula written in terms of W. So that means I only want W's up here. So I can't have L's or H's. Well, in math, we can change the way things look, meaning if this is equal to 3W, you can put this in its place. The H right here, you can take out and you can put this in its place. And when we plug in, we use parentheses. So I'm going to plug in, I'm going to go 3W. This W is okay, so I'm going to leave it like that. Then another parenthesis, W plus 4. Does that make sense so far?
Yeah.
All I did is I replaced these things with what they're equal to, and I use parentheses for a reason. When I multiply, I'm just going to multiply this times this. Well, what's 3W times another W? What is 3W times W?
Would it be 3W squared?
Yes, it would be. And then I'm going to take that 3W squared, and what am I going to do with it here? Pretend like this is a 2. So you guys have to start doing this stuff. Pretend like there's a 2 here, okay? If this was a 2, what would you do with that 2, Nina?
Do you just distribute it?
Right. You would go this times this and this times this, right? This
Yeah.
is the same exact problem, except it's just looks a little bigger, but I'm still going to take this right here, times it by this, and I'm going to take this right here and times it by that. So what is 3W squared times W? So now it's 3W squared times W. What does that turn to?
3W cubed.
Yes, it does. Oops. Plus, what is 3W times 4?
12W squared.
That is it. There's your answer.
Oh, okay.
I'm sorry I was late. I joined the class when, before the bell rung, but I've just been sitting in the lobby and I had to try to rejoin.
Yeah, no, I tried to tell them. I tried to let you in, but it wouldn't let me. So that's why I kicked you out.
Oh, okay. Thank you.
Questions on homework? Okay. All right, so the new lesson. We have already talked about this in my class. We've already talked about difference of squares. We've also talked about perfect squares, but I'm going to review them with you really quickly. And then we have two new ones for today, which are called difference and sum of cubes. All right, so here we go. Perfect square. Here's what's supposed to happen with this. When I do a perfect square, I'm supposed to recognize it both ways. Here's what I mean. If I give it to you as x plus 3 squared, that is a factored form of a perfect square. You are supposed to be able to take this form and turn it into standard form quickly without having to do this, which is, let's say if I'm on the SATs and I forget how to do this, yes, you can do this, but I'm not supposed to have to FOIL this out. That is not what, by the end of today, I should not have to do that. There is a pattern here. And the pattern says, hey, if you have a plus b squared, you can just take the first number, square it. You can take the a times the b and double it. And then you can just square that back number. And that will be the same thing as if you did this whole FOIL junk out. So what I mean by that is the first number I square it. So the first number right here, square it. X squared is x squared. Then to get the middle term, you're supposed to take a and b. So 3 times the x and times it by 2. Well, 3x times 2 is 6x. And then finally, you square this last number, which is 9. This is how you are supposed to go from here straight to here and very quickly. That is what this lesson is intended for you to be able to do. Not only is it supposed to be able to do that way, you are also supposed to be able to go this way, meaning I give you this, and you should be able to look at it to make this happen. So what that looked like in my class is the way we did that is we said, hey, what's the square root of this? X. Hey, what's the square root of this? 3. This times this is 3x doubled is 6x. So in my bubble, I put the x, I put this 3, I square it. That's the x, there's the 3. And this sign right here is what goes in there. That is perfect squares. That is something that we have already talked about and discussed in this class. Does anyone have any questions on what I just kind of did? I know I did it quickly, but that's because it should be just a quick review. All right, difference of squares would be when you have something like this. And in the beginning, it would look something like this, some number, and this number has a square root, this number has a square root, this has a subtraction sign, so we would call this a squared minus b squared. And so the a is the square root of whatever was here. So like, what's the square root of x squared? So my a is x in this case. What's the square root of that? B is 5 in this case. And so the formula says you just take a and you add b to it, and 1 you take a and you minus b from it. And so this one up here would become x plus 5, x minus 5. Now, the reason I'm showing it to you like in that form, and I haven't done that before, is because that's the way we're going to do this. A cubed minus b cubed, or plus b cubed. And I'm also going to show you a cubed minus b cubed. This is called sum of cubes. Do you see how sum means addition, and of cubes means there's two numbers that are being cubed? And the formula is, to factor this, it becomes a plus b, and then in another one, a squared minus ab plus b squared. And this one down here becomes a minus b but then a squared plus ab plus b squared. Do you see any similarities?
It's basically all the same except for the signs.
Yep, and here's how I remember it, Kelly. This sign that's right here is the sign that goes in the front bubble. Look, the sign that's right here goes in the front bubble, and the opposite one goes next. Both of these are both plus, by the way. So let's see how we can use this. Well, a cubed plus b cubed equals a plus b, a squared plus ab plus b squared. What the heck does that mean? Well, that means if I had something like x cubed plus 8. Okay, first off, help me out. What is a in this case?
X.
Wouldn't it be a negative? A2,
Nope.
a squared plus ab.
Oh yeah, sorry. I see what you're talking about. I went too fast. Yes. What's the a in this case? Kelly, what'd you say?
X.
Good. What would be the b in this case? Well, do you see how I'm supposed to have some number written to a third power? And right here, I don't have some number written to a third power, so I got to go, okay, that's all right. Mr. Martin says, hey, in math, we change the way things look all the time. So I need to try to be creative and come up with a different way of writing 8. And the way I want to write 8 is I want to write some number to the third power. Does anyone know what number to the third power 8 is?
2.
So instead of writing this as an 8, I'm going to write it as 2 to the third. Can I do that? Can I take the 8 out and can I put 2 to the third in its place?
Yes.
Why?
Because now it means the same thing and now it matches the top.
Good. That's because 8 and 2 to the third are both the same number, right? But the reason I did this is because now I can label my b as what number?
As 2.
In just a minute, I'm going to start calling on you. Remember, if you don't answer me, I'm going to kick you out of the class. I don't care if you don't know the answer, you must give me some kind of response. And if you don't know it, then I'm going to talk you through it. So Madison, what would be my first bubble then?
I'm kind of confused.
Ask me a question then.
I just don't really know how to do it yet.
Okay, do you see how I labeled your A and your B down here, Madison?
Yes.
Do you see how A plus B goes in your first bubble?
Yes. So would it be x plus 2?
There it is. Yes, ma'am. This is a pattern that someone saw. Every time you have some number that is a cubed plus some number that's cubed, it turns into this pattern every single time. Well, the problem is this wasn't written as some number cubed, but it can be written cubed. 2 to the third power. The reason I did that is so I could figure out what my B was. This is my A, this is my B. I need something, there's the something to a third power. This wasn't something to a third power, so I changed it to something to a third power. Does that make a little more sense, Madison?
Yes.
Noah Brown.
Yeah.
What would go next in my second bubble?
Wouldn't it be x squared?
Perfect. Destiny, what would go next?
I'm not sure.
Destiny, do you see that it says negative A times B?
Yeah,
Do you see what A is in this case?
X,
Do you see what B is in this case?
2,
Can you multiply A times B for me and put a minus sign in front of it?
negative 2x.
Thank you. Jonah, what would go last? Jonah Duncan, I need to hear a response or you're getting kicked, bud. All right, well, you can join back, and if you want to join back, you got to be able to participate. Oh,
Said he
He's
doesn't have a
talking to
mic. He
chat.
can't talk.
I just saw it. Well, Jonah in the chat, what does it become? You should be able to. Do you see what B is, Jonah? It's B squared.
I know the answer, yeah.
What is B in this case, Jonah? Yes. So what's the hardest part of this, guys? What do I need to make sure I label correctly? Before I can follow this pattern up here, what do I need to decide?
What A and B are?
Exactly, and sometimes they're going to give it to me like this. Now, remember, it has to be some number, only one like one thing to the third power, plus B to the third power. Do you see how that doesn't match up the way that it is right now? So I need to rewrite this and this. Because my A is not 8x, guys. My A is not 8x. So let's rewrite 8x to the third power. How can I rewrite? We just did this. How can I rewrite 8?
Two to the third power.
And if I can write that as 2 to the third power, do you see how they're both to the third power? I can rewrite that as 2x to the third, because the third would then belong to the 2 and to the x. So remember in math, if you can, that's all I do all day long. I really hope you guys start getting this idea. You just change the way things look. I don't like the way it's written here, so I change it to this. I don't like the way it's written there, so I change it to that. And I can do that because if I simplify this, if I did that out, this would turn back into that. So these two things are equivalent. Therefore, I can take the 8x to the third out and put a 2x all to the third power in its place. Why is it so important for me to understand that? That tells me what my A value is, which is what? Callie, Robert, you guys don't get it what I just did?
Would it be 2x?
Yes.
So it has to be like simplified as much as possible. Then that can be our A.
It's not simplified necessarily, Robert. It's just changed the way it looked. It has to be something to the third power. So this 8 isn't to the third power. So that's not, you got to figure out what the cube.
Oh, okay. Yeah, okay. I get it.
So this had to be something to the third power. So I had to rewrite it.
Yeah, together they're in the third power, but it was only x that is to the third power.
Right up here, this x only had the third power. The 8, that 3 does not belong to the 8. So that's why I had to rewrite it. So I had 2 to the third. Now they both have a third power. So I can rewrite it with just like them, like both of them to the third power like that.
Okay, that makes a lot of sense.
Now what am I going to do with my 27? Samantha? Do I like the way the 27 is written?
No.
What do I need 27 instead of written as 27? I need it written as something to what?
3 times 9 is like.
You're on the right track. I want 27 written as something to the what power though, Samantha?
3 to the 9th power?
No. I need 27 written as third power.
Oh,
I need it written in this kind of form. Do you see how this, I'm trying to make it fit this form and it doesn't right now? So I need to change the 27 to something to the third power, and it just happens that it's 3 to the third power. Now, Nina, what does that mean my b is?
3.
And now I can follow my pattern that I just gave you guys, which says, hey, if this is, you know, I can go a plus b, a squared plus a, or sorry, minus ab, minus ab plus b squared. So Ashton,
Yeah,
what's going to be in the first bubble?
2x plus 3.
Perfect. Noah G, what's going to happen? What's going to be my next thing? What's going to be in this place?
I'm not really sure.
Okay, do you see A on there, Noah?
Yeah.
What is A?
2x.
Okay, what does it tell you to do to A?
I don't know.
Right here.
Right where? One more time.
Right there.
Square it.
Yep. Can you square it for me?
Not really.
Okay. You can't multiply. I need you to try to multiply 2x times 2x, because that's what squaring means, right?
Yeah, would that be 4? Yeah.
4, that would be the 2 times the 2.
And then 4x.
That would be 4x squared.
Yeah, that one.
But this is stuff, if you don't know how to do it, man, I'm not trying to call you out to be mean. But you gotta, these are stuff that we have to know. This is from prior to Algebra 2. If we can't do this, but that means that you gotta seek extra help. You gotta figure this stuff out, especially being where you're at, and you gotta pass it, right? We got to do something to get this going. We can't just sit here and think it's gonna all of a sudden happen. That's why I need you coming to class more, Noah.
I got you.
Okay, next. Isabella. What would be the next thing that I'd write? I'm right here now.
Wouldn't it be 6x?
Careful.
Oh, negative 6x?
Yes.
Yeah.
And then finally, Gil, what would this one be? What would be the last thing I'd put?
I'm
right here.
full.
What?
Hello? Can you hear me?
Yep, what'd you say?
I'm not Soul.
Okay. Do you see B over here?
Yes.
Okay, what does it tell you to do to the B, guys? What does this tell you to do to the B?
Multiply.
Plus 3 squared.
Which is what?
9.
9. Same thing happens with difference of cubes. You're supposed to do A cubed minus B cubed. And I told you it's almost the same exact thing. It's A minus B, and it follows the same pattern almost, except here there's a plus. What you guys aren't getting is you got to change this sometimes. They're not going to give it to you written exactly how. It's not going to be like if I hope that if I said x cubed minus 2 cubed, hopefully you can follow the pattern and go, oh, this is my A, this is my B. It tells me you put A minus B. Okay, A is x, so x minus B is 2, 2. Then it says I'm supposed to square A. Okay, that's this right here. X squared is just x squared. A times B, 2 times x is 2x. And finally, square this, which is plus 4. The problem is they're not going to give it to you like this. You have got to be able to change the way things look so it fits the pattern that we need. Meaning, it might look something like this. And you have to go. You have to go, okay, this is nice. I like that. That's my a, so I know my a is x, but that's not good. That's not something to the third power. And if I'm going to use that factoring technique, I need something to the third power. So it's difference of cubes, possibly. So I go, okay, does 216 have a cube root? And when I put it in my calculator, it does. It's 6. 6 times 6 times 6 actually is the same thing as 216, which means instead of putting 216, I can replace it with 6 to the third power. That's really nice for me to be able to recognize because now I have my A, now I have my B, and I can follow that pattern. The pattern was A minus B, A squared minus AB, or plus AB, sorry, plus B squared. So, Austin, what would be the first thing that I'd put in my bubble? Austin. All right, Daniel. Daniel H.
X minus 6.
Perfect. Eric, what would be the next thing? I just want this one right here. What would go right there?
X squared.
Good. Savannah, what would go next? Savannah? Savannah, unmute, chat, something. Okay. Dominic.
6x. Or,
good.
Yeah.
And then Janina, what would go last?
36 plus 36.
Is this making more sense to you, you guys?
Yeah.
This only works when you have what we call a sum of cubes or a difference of cubes, meaning it might not look like it, but the front number has a cube root. There's either a plus or minus, and then this back number has a cube root as well. All right. Now, some of the other ones that we talked about were the difference of cubes, or I'm sorry, squares. So I told you at the beginning, I need you to do this with, and they're going to start pushing you. They're going to want bigger numbers out of you. Remember, we're doing 4 of them. Perfect square, difference of squares, sum, and difference of cubes. So here we go. This one right here, perfect square example. Without distributing, meaning without doing this, because that's what that means, right? When you have this squared, you means number times itself. Without doing this whole distributing crap that would take forever, I want the answer of this. Well, let's remember the pattern. This is a perfect square. How do I know it's a perfect square? It's a square and it's timesing it by itself twice. That was like this one. When you have A plus B and you squared it, that means it was A squared plus 2AB plus C. So what is A in this example up here? Taylor.
Yeah.
What is my A? Like, see this down here.
Mm-hmm.
What is representing A? What is representing that here?
The 2x squared.
So A, for this example, is 2x squared. Does that make sense? Annabella, what is B representing?
Y to the third?
Yes.
Or y cubed?
Yes. Now, Robert, what would be the thing that I would put first then, following this pattern? What does that tell me would go right here?
2x squared.
Now?
Or 2a. No.
What does it say to do to the A?
I'll square it.
What does that mean that I would do to this number?
Square it.
Times it by itself, right?
Yeah.
So what happens when you take 2x squared and you times it by 2x squared? What does that get you?
4x 2. No, it's 4x in parentheses 2 on the outside, right?
4x to the fourth would be the right answer. Remember, when you have the same basis, you add the exponents.
All right.
Hey, Austin. Austin, you there?
Yeah.
You got kicked out because I called on you and you didn't answer. You have to stay at your computer. I'm calling on everyone. Now that's what I'm doing. And if you don't answer, I'm kicking you out. You're expected to be by the computer the whole time. All right. Kelly, what would go next?
It would be 4x. I don't know. I'm sorry.
No, you're fine. No, let's.
I was trying to do it in my head, and that didn't really work out that well.
Don't do it in your head, Kelly. Write it down.
4 y.
And then times it by y cubed, right? There's the 2. There's the A. There's the B. Well, I can only multiply the 2 times the 2, which kicks to a 4. And then these guys can't multiply, so we just leave them like that. So, and it's a plus sign, right? Plus 4x squared y cubed. Does that make sense now, Kelly?
Yeah, that makes perfect sense.
Oh, this is me. I messed up. I wasn't thinking right here. The pattern should be b squared. Sorry. Tucker, now that I fixed that, what would go last? Right here, what would I do?
Y to the third power?
But what am I supposed to do with y to the third power?
2y to the third power?
No. What does
Wait.
that? It's okay. No, we're talking to it. That's why the talking lets me know what you're thinking, where you're going wrong, so I can fix it. That's why I'm making you guys do this. Read this to me. What does that say, Tucker?
Where?
Right here.
B squared.
What does that mean?
Y times itself? Or y squared? Or y cubed times itself.
So it means y cubed times y cubed, yes?
Yep.
What did I just say? When you have the same bases, what do you do with the exponents?
Multiply them. Or add them, I meant.
Yes, add them. Because really, what does this mean? This means y times y times y. And this means y times y times y, right? It's just 6 y's multiplied together, or y to the 6th power.
Yeah.
So plus y to the 6th power. That is my final answer for that question. You're going to be doing that kind of stuff for homework. And then one more thing, just to show you real quick. Here's how you can use this actually to help yourself with mental math. If someone ever asked you to do 41 times 39 and you don't want to do this old school way of multiplying and you don't have a calculator, you can actually use one of these identities to help you do the multiplication. It's called the difference of squares. Here's what I mean by that. You can rewrite 41 as 40 plus 1. You can rewrite 39 as 40 minus 1. Do you see how you have the same number? 1 plus, 1 minus. That's what difference of squares looks like. And if you remember difference of squares, the middle term cancels out. So all I have to do is do 40 times 40 and the 1 times 1. I can't always do that. The only reason I can do that is because these are difference of squares. So if I do 40 times 40, it's 1,600. I do the -1 times the +1, -1, and so my final answer is 1,599 would be 41 times 39, and it didn't take me a whole day to sit there and do this. This times this, drop the 0, this times this, right? That whole process. 9, 36, 0, 3, 12, 1, 5, 9, 9. Check. Same answer that I got over here. Now you can't do this for every number. Obviously, you can only do this for certain cases where you can rewrite it as a number plus and a number minus, and these both have to be the same. The 40 has to be the same and the ones, but it doesn't have to always be 1. So like if I did 42 times 38, I could do that as well, because I can rewrite this first one as 40 plus 2, and I can rewrite this back one as 40 minus 2. I couldn't do this if I had like 37 back here, because this would be 40 plus 2, and this would be 40 minus 3. And since this isn't the same exact thing as that, only one being plus and one being minus, since it's not how that is, I can't do that process. So it's not very often that you can use that trick. It's a very limited trick. Does that make sense on how you can use the identities to help you with mental math?
Yeah.
So that's what your homework will be on. Please practice perfect squares, difference of squares, sum and difference of cubes. That's what your homework is for this weekend, to know those in and out. Other than that, have a wonderful weekend, and I will see you on Monday. Make sure you're ready to answer. Like I said, I will keep calling on you. If you don't answer, I will be kicking you out.
Bye.
Have a good
Bye, guys. Have a good weekend.